The idea behind solving related rates problems is to relate the rates of change that the problem gives you. Now, there are a few steps to this. Before we can do this, relate the rates of change that the problem gives you, you first need to identify the rates of change. So that's step one. Write this down. Step one, identify all rates of change the problem gives and asks for. So we're going to read the problem together. Let's just start with the first sentence. So pause the video, read the first sentence, and let me know if anything is changing here. If the answer is yes, at what rate is it changing? Okay, so I'll give you a second to do this. Okay, what did you get? So something is changing. The bottom of the ladder is sliding away from the wall. So the bottom of the ladder, the location for the bottom of the ladder, let's go and draw that out actually. So it says a 10-foot ladder. Okay, so a 10-foot ladder is leaning against a vertical wall. So this is going to be the wall, this is going to be the ground, and this is going to be the ladder. It's 10 feet long. Now, the bottom of the ladder, so this is sliding away from the wall. So it's moving away from here, right? Moving away from the wall at a rate of 2 feet per second. So it's moving away, and so that's what's changing. What's the rate of change? Right here. Okay. So if this is sliding away, what can we say about this? If this is sliding away, then this is getting longer, right? Okay, let's say the ladder slides a little bit. So it slides a little bit. The bottom slides away from the wall, right? So it's going this way. And then the new ladder looks like this. It's still 10 feet. But yeah, you can see that this got longer, right? Now it's this long. So this is what's changing. So we should probably assign a variable to what's changing. I'm going to say this is x. If this is x, what does this tell us about x? So x is changing at what rate? Two feet per second. Okay, so change of x with respect to time is 2 feet, so that's dx, and then time is per second. Because here for this problem, time is measured in seconds. Okay. So that's the first sentence. Okay, so let's go back over here. So we're doing step 1 right now. We kind of did step 2 at the same time as well. Step 2 actually is to draw a diagram. Draw a diagram. More on that in a second. Okay, also this is the ground and this is a vertical wall, right? So what kind of triangle is the ladder always going to make with the ground and the wall? It's always going to make a right triangle because this is perpendicular to this. Okay. So we know dx dt is 2 feet per second. Let's move on to the next sentence because we're not quite finished with step 1. What was step 1 again? Identify all rates of change the problem gives and asks for. Alright, so I'll give you a second to pause the video and let me know if anything is changing in the next sentence. Alright. Okay, what did you get? So the top of the ladder is changing. It's sliding down. If we're going to call the bottom of the ladder, if we're going to call the bottom of the ladder, or the distance between the wall and the bottom of the ladder, if we're going to call that x, then we should call the distance between, we should call this length y. Right? And they're asking for how fast. So they're asking for a rate of change. How fast is this? How fast is it sliding down? How fast is this dropping? So rate of change for y. So if rate of change is dx dt, what do you think the rate of change for y will be? Or what should we call it? They want us to find dy dt. Okay. Let's go back over here. Step 2 says draw a diagram, but why are we drawing a diagram? Well, we need to remember our goal. And the goal is to relate the rates of change that the problem gives you. And yeah, with a diagram, it can help you identify relationships between the rates of change in the problem. Okay, so draw a diagram to relate the rates of change with an equation. Right? Like with math, you want to convert words into equations because in math, equations are easier to work with. And that's what we're trying to do here with the diagram. We already did kind of some of it here. We already figured out dx dt is 2 feet per second. But yeah. So how can we relate x and y with an equation? Your hint is that this is a right triangle. So what equation has x and y in it and is about this triangle here? So in geometry, you remember how x squared plus y squared is equal to this squared. So 10 squared's 100. All right, this is the Pythagorean theorem. I'll write it. Okay, I'll write it here. Pythagorean theorem. Okay, so that's how we can relate this. This is how we can relate x and y. Cool. But remember, what are they asking for? They want us to find dy dt. Okay. Now, we haven't quite related the rates of change yet with an equation. We've related x and y. How can we change this equation such that it relates dx dt with dy dt? In other words, how can we change this equation such that it has dx dt in it as well as dy dt in it? What should we do to both sides of this equation? There's no t in here. So if we want a dt there, we would have to take d dt of both sides of the equation like this. So step 3, step 3 would be to take the derivative, right? Because derivative is just another word for rates of change is derivative. Okay. So take the derivative of the equation, and it's usually with respect to t. In other words, taking d dt of both sides of the equation. Okay. So, if you need a refresher on how to do this or how to simplify this, I've got a few videos on implicit differentiation. So I'd recommend you check those out if you need a refresher. But, okay. What's d dt of x squared? What is the derivative of x squared with respect to t? It's going to be 2x and then dx dt. What's the derivative of y squared with respect to t? (2y dy dt). Okay, and if I take the derivative of 100 with respect to t, what do I get? 0. Okay. Now, they told us dx dt was what again? So at this point, we can actually start plugging in values. Yeah. Let's see. Start plugging in values that the problem gives you. Okay, so I'm changing this to 2 then. So 2x times 2 is how many x? 4x. Okay. And they also told us the bottom is 6 feet from the wall. So when the bottom is 6 feet from the wall, what does that tell us about x? It's 6, and then if x is 6, then according to this equation, what's y gonna be? Okay, so I'm going to, whatever I write on the sheet of paper, you don't have to write down when showing your work. Okay, so x equals 6, right? And then we also have x squared plus y squared is equal to 100. So if x is equal to 6, I'm going to change that to 6. 6 times 6 is 36, right? Okay. Take the square root of both sides of this equation, you get 8. Yeah. Right. And then from that you get the y is 8. Should I write it here or should I write it here? Okay, we'll just write it here. Okay, so x is equal to 6, y is equal to 8. Yeah, let's go ahead and just leave this alone. All right, so what are we doing right now? We're plugging in the values that the problem gives you. So let's go ahead and plug in the 6 that they gave us. So 4 times 6 plus 2 times y. Y was how much again? 8. And then times dy dt is equal to 0. What's the question asking for again? It wants us to find dy dt. So we need to get this by itself. So step 4. Isolate the rate of change. And what's another word for rate of change again? Derivative. Okay, so isolate the rate of change the problem asks for. So which rate of change again are they asking for? Dy dt. So we need to isolate it. We need to get this by itself. Okay, before we do that, 4 times 6 is 24, and 2 times 8 is 16. How do we get dy dt by itself? Before I can get dy dt by itself, I need to get this by itself. So we need to subtract 24 from both sides of the equation. Okay. Yeah, actually, in calculus, your professor kind of expects you, or your teacher kind of expects you, like you can just go directly to saying dy dt is equal to, okay, we'll work it out here, but you don't have to show intermediate steps here. yeah, at this point, calculus teacher trusts that you know how to do this, you know to figure it out on your own. But okay, I'll just elaborate a little bit here. Okay, so 24 plus 16 dy dt is equal to 0. All right, so we wanted to get this by itself, right? Before we can do that, we need to get this by itself. So let's subtract 24 from both sides of the equation. And then how do I get this by itself? What do I need to divide by on both sides of this equation? Divide by 16. What does this fraction simplify as? What can I divide out of the top and the bottom? I can divide out 8. That's the biggest I can divide out. 24 divided by 8 is 3. 16 divided by 8 is 2. So we're left with negative 3/2. Okay. So that is step 4. Okay. Now, when moving this way, right? Moving this way is positive. Moving up is positive. Like, yeah, if you think of it, right? If I were to draw the XY plane, right? Like, let's say, so this is the x-axis, this is the y-axis. This is what we call the XY plane. This is where we graph points, right? Let's say I wanted to plot a point here. So, hang on. Let's say I wanted to plot 1, 2, right? When I plot 1, 2, if I go to the right, that's for whenever this is positive, right? So go to the right whenever the x-coordinate is positive, and go up whenever the y-coordinate is positive, right? The negative y-coordinates would be this way. Yeah, it's the same idea with what we're doing right now, right? Like this, and then we've got x is the horizontal. So if we go to the right, it's going to be positive. If we go up, it's going to be positive. Yeah, this is just by convention. But yeah, if it's negative 3/2, then in what direction is y? In what direction are we moving for y? So going up is positive. We're going, if we have a negative, we would be sliding down, and dy dt would be 3/2. We're not finished with this problem yet. Step 5 is to include your units. Okay, so it is sliding down at 3/2. Sliding down at 3/2. 3/2 what? It's sliding away at a rate of 2 feet per second. So x is measured in feet, right? dx dt is measured in feet per second. So what do you think? Okay, so if dx dt is measured in feet per second, what do you think dy dt will be measured in? Feet per second. This is your answer. But yeah, write this stuff down. These are the steps to solving related rates problems.